Good morning and Jai Hind children. I welcome you all in today's live class of chemistry. Okay children, as you know that we are discussing the chapter physical and chemical changes. And in previous class I have discussed all the short answer type question. Is it children? So I hope that you understood all the answers of those questions. Alright, now today I'm going to discuss the next exercise of the book, that is long answer questions. Okay children, and the question number 1 is, the question number 1 of the exercise is, discuss the method by which rusting of iron can be prevented. Okay children, again I am repeating the question, that discuss the method by which rusting of iron can be prevented. So children, simply the answer you can give as, there are different methods by which we can prevent the rusting. Okay, and the rusting can be prevented by not allowing the iron to come in contact with moisture and air. Alright, and the two methods by which rusting of iron can be prevented are, the first one, yes, by coating the iron with oil or grease or paint. If we coat our iron articles with these materials, so they will not get rusted. And the second method, by depositing a layer of zinc or chromium on the iron. Alright children, so if we are going to use any method, so we can prevent the rusting and we can protect our iron articles. Alright, now come to the question number 2. Question number 2 is, which gas is given off when dilute hydrochloric acid is added to calcium carbonate? Alright children, and how will you taste the gas? And also write the chemical equations for both the reactions. Get it children? So in this question you have to first give the answer, what will happen when dilute hydrochloric acid will add it to calcium carbonate. After that you have to write that which gas will produce, and you have to write the chemical equation for it also. Get it? So come one by one, that when dilute hydrochloric acid is added to calcium carbonate, so the gas which is given off is carbon dioxide. Alright, which gas? It's carbon dioxide. Okay, and the chemical equation is calcium carbonate. Children, the formula is CaCO3. When this calcium carbonate is going to react with dilute hydrochloric acid, and the formula of hydrochloric acid is HCl. Okay, so when the reaction will take place, it will form the products. The first one is calcium chloride, CaCl2. Okay children, the formula of calcium chloride is CaCl2. Along with it, two more products will form, and that is water, and one more product in form of gas, that is carbon dioxide. Okay, so these are the products which will form when calcium carbonate will react with dilute hydrochloric acid. Got it children? And now you can balance it. So this is a balanced equation in which we can say that when calcium carbonate reacts with dilute hydrochloric acid, it forms calcium chloride, water, and carbon dioxide. Okay, children? Now, we can taste the gas which is given out here by passing it through the transparent lime water. Alright, children? And it turns milky and white after passing carbon dioxide in it, and the reaction can be written as calcium hydroxide. The formula of calcium hydroxide is, yes, CaOH twice. Got it, children? Now when this calcium hydroxide, we will pass carbon dioxide gas which was produced here. So when this carbon dioxide gas get mixed with calcium hydroxide, it forms a milky white solution, and that is calcium carbonate. The formula of calcium carbonate is CaCO3, and along with it, it will also form water. Alright, children, so this is the chemical equation in which the carbon dioxide, when passed in calcium hydroxide is transparent liquid. Okay, so when this carbon dioxide passed in this calcium hydroxide, it turns in milky white solution. That look is calcium carbonate, and along with it, water will also form. Got it? So this is the answer of question number 2. Alright, children? Understood? Now, come to the next. Question number 3. Okay? And the question number 3 is, explain the steps involved in preparing the magnesium hydroxide from the metal magnesium. Get it? What you have to write here? You have to write the steps like procedure. Okay, and in these steps you have to write how the magnesium hydroxide can be formed from the metal magnesium. So children, remember that we have performed an activity in the lab in which we have done the same. We have taken the magnesium ribbon, we burned them and forms the ash, that is magnesium oxide, and after that dissolving in water we form the magnesium hydroxide. So here you have to write the same steps. Got it? So you can write the answer as the following steps are involved in preparing magnesium hydroxide. Okay, the first step is, take a small piece of magnesium ribbon, clean its tip with sandpaper and hold it with a pair of tongs and bring it near a flame. Got it, children? This is the first step. In second step, it burns with a dazzling white flame. Okay, that magnesium will burn how? With a dazzling white flame. And at last, a powdery ash, which is magnesium oxide, that does not look like the magnesium, is formed. Okay, so in second step, what is formed? Magnesium oxide in form of powdery ash. Get it? Now, in third step, what we have to do? Collect the ash and mix it with a small amount of water in a test tube and stir it. Okay, and when magnesium oxide dissolves in water, it forms the magnesium hydroxide. Got it, children? So you can write the answer as, In first step, we will take the magnesium ribbon and we will burn it in presence of oxygen. Okay, and after burning, we will get a white powdery ash, that is magnesium oxide. Alright children, the formula of magnesium oxide is MgO. Get it? Now, collect these ash and mix it with a small amount of water. So when this magnesium oxide mixed with water, we will get the, yes, magnesium hydroxide. Alright children, so this one is the chemical equation which shows that when magnesium burns in presence of oxygen, it forms magnesium oxide, which is the ash, powdery ash. Okay, and the equation you can balance it. Now, when this magnesium oxide mixed with water, it forms the solution, and that is magnesium hydroxide. Alright, children, is it understood? So, this is your answer number 3. Now, come to the answer number 4. Okay, so the question is, a decomposition reaction is the opposite of combination reaction. So, explain with the help of an example. Okay, children, what you have to write here in question number 4? A decomposition reaction is the opposite of combination, that we know. Okay, so here you have to explain it with the help of an example. Get it? So, come to the answer number 4. Till first of all, you will write about the combination reaction. Okay, so how we can denote the combination reaction? Denote means how simply we can indicate the occurrence of a combination reaction. So we already have discussed in the chapter, children, when two different substances combine together and form a single substance. Okay, so such a reaction is known as combination reaction. So we can write as when A and B, these two substances react together and form a single substance, that is AB. Okay, so this is the simple, yes, indication of combination reaction. And in example, we can write as that when, yes, the two gases, hydrogen and oxygen, combine together, it forms a substance, that is water. So it is an example of combination reaction. So the example of combination reaction is, children, when hydrogen gas and oxygen gas, when these two gases combine together, react together, they both get combined and forms a single substance, that is water, H2. Okay, and we can balance it. So this is a balanced chemical equation in which two different substances are going to combine and form one substance. So we can say that this is the example of combination reaction. Alright. Now the second difference you can write as, in combination reaction, that compounds is formed from simpler substance. Okay, as here you can say that A and B, these two are the simpler substance, and when they both are going to react together, they are going to form a compound. So this AB is a compound, and how this compound form? from these two simpler substances. Get it? Now come to the decomposition reaction. Children, decomposition reaction is just opposite to composition reaction. Okay, in decomposition reaction what happens? A substance breaks, decomposed into simpler substances. So it is just opposite to it, and we can denote it as when a substance, say AB, during a chemical reaction going to decomposed into A and B. So this is the simple indication of decomposition reaction. Okay, this denotes the decomposition reaction. And the example of this decomposition reaction is, children, just opposite to this. When the water is going to electrolyze, when electric current passed in water, it breaks into hydrogen gas and oxygen gas. Okay, so we can write the example. When electric current passed in water, it breaks into hydrogen gas and oxygen gases. Okay, and we will balance it like this. So this is a balanced equation which shows the decomposition reaction, because here the substance or this compound get decomposed after the reaction into simpler substances, that is hydrogen and oxygen. Alright children, and the second difference is that in decomposition reaction what happens, a compound breaks up into two or more substances. Okay, so these are the differences between combination reaction and decomposition reaction. Understood children? Okay. Now come to the next question, that is question number 5. Okay, and the question number 5 is, under which condition do decomposition reactions normally takes place, and give one example of each. Got it children? Understood the question? In question what you have to write? You have to write the two conditions. Okay, for what? For decomposition reaction. So what are the two conditions in which decomposition reactions normally takes place? And you have to give one examples for both the conditions. Okay, so come to the answer. So the answer number 5, and the two conditions are, the first one is by heating the substance. Okay, when the substances get heated, they decomposed and breaks into simpler substances. So the first condition is by heating. Alright children, and the example of this one is when calcium hydroxide, which substance? Calcium hydroxide, and the formula is CaOH twice. Okay children, so when this calcium hydroxide heated, it breaks into simpler substances, and those substances are calcium oxide, CaO. Which compound is this? Yes, calcium oxide, and water. Okay children, so you can say that when the compound calcium hydroxide heated, it breaks into calcium oxide and water. So this is the example of decomposition reaction. And what is the factor here? Yes, the factor is heat, because without heating this reaction will not complete. Okay, now the second factor, Second factor is by passing electricity, okay, through the solution. When electric current passed in any solution, so that solution breaks into simpler substance. So that also indicates the decomposition reaction. So second factor by passing electricity, and the examples of this factor is, yes, as we already have done, when when we pass the electricity in water, it breaks into, yes, simpler substances, and that substance is hydrogen gas and oxygen gas, and balance it. So this is the chemical equation in which, yes, the substance is going to break into simpler substance by passing electricity in that solution. Got you, children? So these are the two factors. The first one by heating the substance, and second one by passing electricity through the solution. What will happen? This reaction will happen. Decomposition reaction will take place. Alright, children? Got it? Okay, so I hope that you understood the answer of question number 5. Okay, now come to the question number 6. Okay, the question is, what is a displacement reaction, and which rule governs displacement of an element in a compound by another element? Explain with an example. Children, understood the question? Once again, I am going to repeat the question. What is a displacement reaction? So first of all, you have to define the displacement reaction. Okay. After that, which rule governs displacement of an element in a compound by another element? In second, you have to write that what is the rule used there in displacement reaction. And at last, explain it with an example. You have to write an example for it. Got it? So come to the question number 6. So, children, you know the definition of displacement reaction because we have already discussed in the chapter, is it? So, the chemical reaction in which one element replaces another element is known as displacement reaction. Is it? This is the definition. And the rule of displacement reaction is that a more reactive element replaces a less reactive element from its compound. Alright, what is the rule? The rule is displacement reaction is that a more reactive element replaces a less reactive element from its compound. Children, you have to remember it. Okay, less reactive element will not replace the more reactive. Only the more reactive element will replace the less reactive element from its compound. So this is the rule for displacement reaction. Okay, and we can write it as when this substance A is going to react with another compound BC. So what will happen here? The displacement of, yes, C will occur and it forms AC plus B. Okay, as A is more reactive than B, so it displaces the B, okay, from its yes, solution. Get it? And example, copper sulfate. Children, we have done an activity, is it, in the lab? So remember there, we have done the same displacement reaction in that activity also. In copper sulfate solution, when we add the iron metal, so when iron is added in copper sulfate solution, so what will happen? As iron is more reactive than copper, so it will displace the copper from solution and forms iron sulfate. Which compound is this? Iron sulfate. And the copper is as a less reactive than iron, so it will get replaced. Got it, children? So this is the chemical equation of displacement reaction. In this, what will happen? Iron is more reactive, so it displaces the copper from copper sulfate. Okay, and forms the iron sulfate. So in this reaction, you can say that iron is a more reactive element than copper. So iron displaces copper from copper sulfate. Got it? Is it, children? Now come to the next question, number 7. Okay, and the question is, what is a double displacement reaction? And how many types of double displacement reaction do you know of? And give one example of each. Got it, children? The question, once again, I'm going to repeat. What is a double displacement reaction? So you have to define the double displacement reaction. And after that, you have to write how many types of double displacement reaction do you know of? And at last, give one example of each type of double displacement reaction. So come to the answer number 7. So, children, the definition of double displacement reaction is, yes, in a double displacement reaction, two compounds react by exchanging their radicals. Okay, so we can say that what happened in double displacement reaction? Two compounds react by exchanging their radicals, and we can indicate this reaction as AB. This is the first compound when react with second compound, that is CD. So what will happen? They both will get displaced. It will form A, D and plus C, B. Okay. So this is going to displace here. So this is the double displacement reaction. Got it, children? Now, there are two types of double displacement reaction. And the first one is precipitation reaction. The first type of double displacement reaction, children, is precipitation reaction. Okay, precipitation reaction simply indicates for what? The formation of a precipitate. Okay, so the example of this precipitation reaction is when sodium chloride reacts with silver nitrate. The formula is AgNO3. Okay, so this is silver nitrate and NaCl, this is sodium chloride. When they both will react, double displacement reaction will take place and it will form silver chloride, and this silver chloride will form as a precipitate. So we will indicate it by downward arrow. And the second compound, that is sodium nitrate. Alright, children. So these two compounds will form in this precipitation reaction. So the double displacement reaction is going to occur here, but one of them is formed as a precipitate. So we can say that it is a precipitation reaction. Get it? Now the second kind of double displacement reaction is neutralization reaction. Okay, children? Second double displacement reaction is neutralization reaction. And in this neutralization reaction, when sulfuric acid reacts with sodium hydroxide, formula of sulfuric acid is H2SO4. And when this acid is going to react with a base, that is sodium hydroxide. So one acid and one base, they both are going to react together and form sodium sulfate and plus water. And we can balance it as, got it, children? So this is the neutralization reaction. In this reaction, what happens? This acid and base, they both react together and neutralize this effect and form a salt, that is sodium sulfate and water. Get it? So these are the two type of double displacement reaction along with their examples. Understood, children? Now come to the question number 8. And the question number 8 is, explain the terms oxidation and oxidizing agent. So children, you have to define the term oxidation. Okay, oxidation is a chemical reaction that involves addition of oxygen or removal of hydrogen from a substance. Get it? So what is oxidation? Yes, addition of oxygen or removal of hydrogen from a substance. So this chemical reaction is known as oxidation reaction. And example is when carbon react with oxygen, it forms carbon dioxide. Okay, children? So this is the one reaction of oxidation, because here oxygen is going to add it in carbon and forms carbon dioxide. Get it? Another example is H2S, hydrogen sulfide, when it's going to react with chlorine. Okay, it forms sulfur and hydrochloric acid. So sulfur and hydrochloric acid will form. So here in first one, oxygen get added in carbon and forms carbon dioxide, and here hydrogen gets, yes, removed. This chlorine has removed the sulfur and forms hydrogen chloride. Get it, children? So hydrogen get removed from the sulfur, from hydrogen sulfide. So this is also the example of oxidation reaction. Okay, and the oxidizing agent is, an oxidizing agent is one that oxidizes other substances by providing oxygen to them or by removing hydrogen from them. So such an substance is known as oxidizing agent. So in first equation, who is oxidizing agent, children? Yes, oxygen is the oxidizing agent. And second one, chlorine is the oxidizing agent. Because they both have, yes, oxidizes the oxygen. Get it? So these all are the long answer type questions. Okay? And in next class, we will discuss the HOTS question. So thank you and have a nice day, children.